Hello everyone, welcome to the third video in this series. What we're going to focus on today is still solving linear equations, but we are focusing on case 3 that deals with equation containing multiplication. So let's look at some examples. Example 1, we are asked to solve for a in the equation 5a equal 35, right? Now, what does 5a mean? 5a means 5 times a, right? So what we want to isolate a by itself. Or in other words, we want a to have a coefficient of 1. So how can we do that? We can do that by doing the opposite. So note, originally, we are taking 5 to multiply a. So if we want the coefficient to be 1, which will give us a by itself, then we are going to divide both sides by 5, right? So step 1, divide both sides by 5. How would you state this in your book? You would state this as 5a all over 5 equal to 35 all over 5. So note the original problem compared to what we did here. All we are doing is just dividing both sides by 5. That's all. When you divide both sides by 5, you're going to simplify. When you simplify, all you would end up with is just a equals 7. How do you know? Because 5 into 5 here will give you 1, and 1 times a is just a. And 35 divided by 5 is just 7. Now, to check if your answer is correct, note that we said that a is 7. So in the original problem, if you replace a with 7, then what we'll have is 5 times 7, which is 35. So yes, our solution is correct. Let's look at example 2. We're now given 4p is equal to 12. Right? So again, note that 4 is multiplying p, and we want p by itself. So how can we transfer this 4 over to where 12 is? We can do that by just dividing both sides by 4. How would you state this in your book? You would state this as 4p all over 4 equal to 12 all over 4. What would you do at this stage? You're going to simplify. When you simplify, note that your solution is just p equal 3. How do we know? Note here that 12 divided by 4 will give us 3, and 4p over 4 is just p. To check quickly, in the original problem, we have p replace p with 3, so 4 times 3 will give us 12. So therefore, our solution is correct. Let's look at the third example. We are now given 5 is equal to 2x. Now the variable is on the right-hand side. Does the principal change? No, it does not. So here we want x by itself. How can we get x by itself? By dividing both sides by 2. How would you state it? You would state it as 5 over 2 equal to 2x all over 2. What would you end up as your solution? Your solution is going to be x equal to 5 over 2 or 2 and 1/2. How do I know that? Note here that 2x over 2 will just leave you back with x. And you can write your answer as an improper fraction or a mixed number. All right, let's look at our final example. We have 6y is equal to 18. What is our objective? We want y by itself. How can we get y by itself? By doing the opposite of multiplying by 6, which is to divide both sides by 6. How do you state this? You would state this as 6y all over 6 is equal to 18 all over 6. Then what are you going to do? You're going to simplify, and that will give you a solution. So note, 6 divided by 6 is 1, and 1 times y will give you y. And 18 divided by 6 will just give you 3. Let's do a quick check. If we replace y with the value of 3 in the original problem, we'll end up with 6 times 3. That will give us 18. So therefore, our answer is correct. Now that I know that you have mastered this concept, you can now try these questions on your own. Thank you for watching, and do enjoy the rest of your day.